In today's world, there's just so much information flying around. It feels like you blink and there's a new concept you're supposed to understand, right?
Absolutely. It's easy to feel overwhelmed.
So today, our mission is tackling one of those big ones, cloud computing. We hear it everywhere. It shapes, well, almost everything.
Hmm.
But what is it, really? We want to break it down, make it clear, and basically give you a shortcut to feeling, properly informed.
And we're focusing specifically on the foundational layers: infrastructure as a service, platform as a service, and software as a service.
IaaS, PaaS, SaaS. Got
Yes,
it.
the acronyms. But understanding these categories isn't just tech talk. It's really key to grasping modern digital infrastructure, how it all works.
Totally. And like always, this deep dive is built just for you, using sources provided specifically for this exploration. So it should be super relevant.
Ready to jump in.
Okay, let's unpack this. So first things first, the absolute core. What is cloud computing?
Well, fundamentally, it's a way to get computing resources. Think storage, servers, databases, software, but over the internet.
Right, so not on a computer physically sitting in your office or home.
Exactly. The big shift is you don't own or manage the actual physical hardware. Someone else does.
I kind of like the analogy of renting an apartment versus buying a house.
Oh, that's a good one. Yeah.
You get the fully furnished space, the computing power, the storage,
Mm-hmm.
but you don't have to worry about fixing the roof or upgrading the plumbing, the maintenance.
Right. And you
Right.
generally pay for what you use, which is a big part of it.
So who is the landlord in this scenario? Who provides all this?
That's where the big cloud service providers come in.
Mhm.
Companies like Amazon Web Services, AWS, Microsoft Azure, Google Cloud Platform, GCP.
Okay.
They operate these massive data centers stuffed with all the physical hardware, and they manage it all.
What are the main advantages then? Why rent instead of buy, so to speak?
Well, flexibility is huge.
Yeah.
It's usually very cost effective, especially starting out. And critically, it's scalable.
Scalable meaning you can easily get more or less computing power.
Exactly. Need more server space for a big sale, you can ramp it up. Quieter period. Scale it back down quickly.
That sounds way easier than buying new servers every time.
For sure. Think about a small business. They don't need that huge upfront investment in servers for their website or data storage. They can just, rent it.
And reliability. Is it safe?
Generally, yes. The providers handle security, backups, making sure things stay online. That's their business. High availability is key.
Okay, that makes sense. So the cloud is this sort of collection of rentable computing resources.
Right.
But you mentioned different layers.
Right. IaaS, PaaS, and SaaS. They offer different levels of control, flexibility, and management. This is where it gets really interesting.
Let's dig into that first layer then. Infrastructure as a service. IaaS. What's that about?
Okay, so IaaS gives you the most basic building blocks. Think virtual machines, raw storage, networking, all delivered over the internet.
Virtual machines. Like a computer, but just software.
Kind of, yeah. It runs on physical hardware somewhere else, but you get your own slice, your own operating system to install your own software.
So back to the house analogy. Is this like just renting the land?
That's a great way to put it. Renting the plot of land, maybe with the basic utilities like water and power hooked up.
But I still have to build the actual house myself.
Exactly. You install and manage the operating system, the applications, your data. You build the house.
So the main feature is control.
Control and flexibility, definitely. You choose the OS, configure servers, decide on storage, processing power. It's very customizable.
And scalable, you mentioned.
Hugely scalable. An online shop, for instance, could add tons of server capacity just for the holiday rush, then scale back down in January. You only pay for what you need when you need it.
So you manage the software, they manage the hardware underneath.
Precisely. The provider handles the physical data centers, the servers, the storage hardware. You handle everything above the operating system, basically.
Got it. What are some examples of ISC's providers or services?
Well, the big players offer this. Amazon's EC2, that's their Elastic Compute Cloud, Google Compute Engine. Microsoft Azure Virtual Machines, those are classic IaaS offerings.
And who uses this typically?
IT professionals, system administrators, maybe a startup that needs very specific server setups for a new website or application but doesn't want to buy a physical kit.
Okay, that makes sense. Maximum control, but you do the building. Let's move up a level then. Platform as a service, PaaS.
Right, PaaS. Now, think of this like renting a fully equipped professional kitchen.
Okay, equipped how?
It's got the ovens, the mixers, maybe even some basic ingredients and recipes ready to go. The tools, the frameworks, the development environments.
So it's specifically for building things, like software.
Exactly.
Hmm.
PaaS provides a platform for developing, testing, and deploying applications without you having to manage the underlying infrastructure. No worrying about servers, operating systems, patches.
So the kitchen owner handles all the maintenance, keeps the appliances running, stocks the pantry.
Yep. The PaaS provider manages the OS, the server updates, the hardware. You, the developer, just focus on cooking your dish, writing your code, building your application.
That sounds like it would speed things up considerably for developers.
It does big time. Ease of development is key. Plus, it often makes collaboration easier because the whole team is working in the same managed environment.
Less management overhead, faster development. Makes sense. What are some common PaaS examples?
You've got things like Google App Engine, Microsoft Azure App Services, Heroku is another popular one.
And a typical user might be.
A developer or a development team wanting to create a new web or mobile app quickly. They use PaaS to get a ready-made environment with coding tools, databases, everything they need without getting bogged down in server admin.
Okay, I see the progression. Less control than IaaS, but easier for building applications. So what's at the top? Software as a service. SaaS.
SaaS, and this is the one most people interact with daily, probably without even thinking about it.
How so?
Think of SaaS like streaming a movie on Netflix.
Yes.
You don't own the movie, you don't own the servers it streams from, you don't manage the Netflix platform, you just log in through your browser or app, pick what you want, and watch.
And Netflix handles everything else, making sure it plays, adding new shows.
Exactly. The provider takes care of everything, the software, the updates, the infrastructure, the maintenance. It's ready-to-use software delivered over the internet.
Like renting a fully furnished, fully serviced apartment.
Perfect analogy. You just move in and use it. No installation, no technical setup needed on your end.
So key features are ease of use.
Absolutely. Super easy to use. It's usually subscription-based pay, monthly or yearly, so no big upfront cost for software licenses or hardware.
And updates.
Automatic. The provider pushes updates, security patches, new features. You don't have to do anything. It just works.
That sounds like pure convenience. What are some everyday examples?
Oh, tons. Google Workspace, Docs, Sheets, Gmail,
Yeah.
Microsoft 365, Dropbox for file storage, Zoom for video calls. These are all SaaS.
Right, I use those all the time.
Yeah. And a typical use case is, say, a small business using Google Docs. Employees access it online, collaborate, save files. Google handles the storage, the software updates, the security. It just works.
Okay, so we've walked through IaaS, PaaS, and SaaS, the three main layers. Bringing it all together, what does this actually mean for you listening? Why does understanding these types matter?
Well, it really shows how the cloud caters to different needs by offering different levels of abstraction and management. It's about choosing the right tool or the right rental for the job.
So IaaS is
For those needing the raw infrastructure, the most control, think IT pros setting up complex custom environments. The build-your-own-house crowd,
Sure.
ideal for developers. They want to focus purely on coding and deploying apps, not managing servers or operating systems. The rent-the-kitchen folks.
Our most soars.
That's for the end users, really. Individuals, businesses who just want to use software easily without any technical hassle, renting the fully furnished apartment, plug and play.
So these categories, these layers, they make cloud computing accessible and useful for almost everyone, right?
Exactly. It's not just one monolithic thing. This structure powers everything from tiny mobile apps to huge global corporations. It makes technology fundamentally easier to access, cheaper to start with, and much more flexible.
Okay, I think I've got a much clearer picture now. We've journeyed through those core layers, infrastructure, platform, and software as a service. You should now have that foundational grip on the different ways cloud services are offered.
Yeah, and maybe a final thought to chew on. Now that you can see these distinct layers, IaaS, PaaS, SaaS, this structured way of managing complexity, how might that apply elsewhere?
What do you?
Well, think about other complex systems or technologies you encounter, things that seem like a black box. Could viewing them through a similar layered lens, understanding the different levels of control or service involved, help you analyze them better?
Like understanding what's really going on beneath the surface.
Exactly. It might help you make more informed decisions, whether it's choosing a service or just understanding how the digital world around you actually works, looking beyond the simple interface.
That's a really interesting way to think about it, applying this framework more broadly. Definitely something to consider. We hope this deep dive has been useful, and we really encourage you to keep exploring these ideas.